on epic hail. All right, so in order for us to actually do extreme weather, right, which is going to be crazy and fun to watch, right, you need to know where it's coming from. So before we can do anything else, you need to know where it's coming from. Well, where does extreme weather coming from? It comes from clouds. So you need to know how clouds form. Now, I'm going to tell you what I tell all of my classes. These steps, you're going to want to know, live, love, learn, memorize, sleep with, whatever it has to do in order for you to understand this is how clouds form. Okay? Right? Whatever it is, right, you need to know these steps. These steps show up at least for 2 questions every year on the Regents, which means that it's going to show up on my test, which means it's going to show up on my quizzes. So you need to know what order and what the steps are. And what I did for you guys is I highlighted the key words for each step. Okay? So step 1, in order for a cloud to form, you need warm, moist air on the ground. Right? That warm, moist air. We know when molecules warm up, they move faster and they rise up because they become less dense. Why do they become less dense? Because they move apart from one another. Right? The air is going to expand as they rise up. Okay? That makes more room for more moisture because the air is up there. Right? Why does it expand? It expands because you have low pressure surrounding those molecules. Right? If it's low pressure, it means that they're not squeezing them all together. They're giving them some room. Here's step 3 and step 4, okay, are the ones you're going to want to highlight because these are the ones that I see a lot. Okay, so now you have this air up in the atmosphere. You have these air molecules up in the atmosphere. Okay? They're in gas form, right? Those water molecules are water vapor. They're in gas form. Well, in order for precipitation to occur, the air temperature and the dew point temperature have to be very close to each other, if not equal to each other. Okay? I will say it again. In order for precipitation to occur, the air temperature and the dew point temperature need to be close to, if not equal to, so the air temperature and the dew point temperature need to be close to, if not equal to, each other. Okay? You will not get precipitation if the air temperature and the dew point temperature are not relatively close. Okay? That means they could be off by like 5 degrees or less, I would say, for your sake. Usually in questions like that, they'll give it maybe a degree or 2. Okay, so step number 3 is very important. Okay, so the air temperature and the dew point temperature need to be equal to each other in order for a cloud to form, so that you end up getting that water vapor inside the cloud, or inside the air, I should say, condensing down to form that cloud. Okay? This is why you can fly through clouds. Clouds are just basically water vapor, okay, that have condensed down a little bit and float. Okay? Everybody okay with that? Good? Everybody at home, you good with that?
Yes.
Awesome. So this is really important that you understand how a cloud forms because without the cloud, you don't have precipitation, okay? So clouds are basically water vapor that has risen up, has cooled down to reach the dew point temperature so that the water vapor condenses, and then you get a cloud. Now, here's just a picture of that basically happening, okay? Step one, like I said, you get the sunlight that has to warm the surface first, which then makes the water vapor evaporate, okay? This will happen in basically a convection current, all right? All right, I love this picture. And the reason I love this picture is because it gives us a ton of information in one picture. Now, I want you to look at it. I want you to give me one conclusion that can be drawn or one observation about this picture.
My observation is that the temperature of the air temperature and the dew point temperature are the same, so it forms a cloud because of precipitation forms.
Sure, where am I looking?
At the top.
At the top. So the air temperature and dew point temperature are the same, and therefore we have a cloud. Okay? What else can you see on this?
The dew point temperature doesn't change.
Dew point temperature does not change. Very good. So dew point is not affected by altitude. There's a good conclusion. What else can you notice? What about the temperature, ladies and gentlemen?
Temperature is affected by altitude.
Absolutely. Temperature is going to be affected in, do you remember what kind of a relationship is that? Is that a direct or an indirect relationship?
Indirect.
Yeah, right. Direct goes both up or both down. Indirect is one up, one down. Good job. Okay. So, couple of things to notice about this, right? First one was that the temperature is decreasing as you increase in altitude. We know this to be true. If you forgot, you could look on your reference table and look at the graph of the atmosphere. Second thing is, the dew point is not affected by the altitude. It's not, right? And in order for a cloud to form, the dew point temperature has to be equal to the actual air temperature, okay? So let's talk about clouds some more. There are a couple types of clouds, right? There's a land-hugging cloud known as fog. You have all seen it before. Driving, you see it most of the time right over water, right? And if you think about it, it should make sense. A couple weeks ago, when I was driving my kids to babysitter, right? I have to drive on the cross island, and over on the right-hand side where you see the water,
There's always a lot of fog.
there's usually a lot of fog there, and you can't see across the entire lake, right? And the reason is, think about it though, right? You need warm, moist air to rise up in order for a cloud to start forming, right? Water has a higher specific heat, which means that it's releasing the heat at a much slower rate. So even though it was cold on the surface and there was snow on the ground, clouds were forming over the water because it was much warmer and giving off the heat. Kind of cool, right? The second type, before we get into the clouds in the sky, all right, is known as a low density cloud. You guys know this as haze. Haze to me looks like your eyes went blurry. Okay? It ends up being, it's in between fog and regular clouds. It's kind of like mist. It really just honestly happens when it's extremely hot out and it's like during the summer months for us here, right? So this is fog, right? I don't know why every horror movie I've ever seen where people are walking through graveyards, it's foggy, because it looks creepy. But I've been to plenty of graveyards where it's not foggy, okay? I don't know, it's part of the illusion of being in a horror movie, right? Versus this, which is haze, okay? If you look here, right at the skyline, it kind of, you can, and a little bit higher too, right? It looks like there's just like a very thin sheet over the buildings, right, that make it a little bit blurry, like you have to dial your glasses a little bit more, right? If you ever gone for an eye test, I'm like, which one looks better, one or two?
Miss Gonzalez,
What's up?
sorry to interrupt. Is your camera off?
No? Why?
Can I call back and join the meeting? I don't.
Absolutely you can.
Thank you.
No problem. I'm recording it too, so just in case you miss anything. Okay? Come on. Come on. Okay. Ah! Too far. If you want to take a picture of this, you may. Okay? This is just remember, don't get anybody else in the picture. Okay? This is the clouds that we see in the sky. All right? So we had fog, which was the land-hugging clouds, right? We had haze, which was in between the land-hugging and the atmospheric clouds. And now we have the types of atmospheric clouds. Okay? Stratus is the ones where it's like the nice, fluffy clouds outside, right? The cirrocumulus, the altocumulus, right? The cumulus, the cirrus. Cirruses are like the wispy ones, right? The ones that we see most often are the stratus clouds. You guys at home still there?
Yeah.
Good. Okay. The stratus clouds are like the nice, white, fluffy clouds that you see outside. You know it's not going to rain. You just see it and it's like, oh, there's Mickey Mouse. Right? Those are the stratus clouds. The ones that actually have weather with it or precipitation with it are the nimbostratus and the cumulonimbus. The cumulonimbus cloud is where we're going to get our thunderstorms. Okay? Because there's a lot of stuff going on inside the cumulonimbus cloud. There's a convection current that happens inside the cumulonimbus cloud that creates storms. Okay? So whenever we say a thunderstorm is happening, you should look for a cumulonimbus cloud. I actually have to find one. Over the summer, I was able to capture a picture of it. I'm going to have to actually find it and post it for you guys. Okay? So those are clouds. All right? Now we're going to talk about precipitation. Now, the definition of precipitation that you know about, right, is going to be wet stuff falling out of the sky, right, in some way, shape, or form. And you're not wrong with that. Okay? No, you're not 100% wrong with that, I should say. Can I find it? No, that's crazy. All right, so basically, precipitation in general is going to be condensed moisture that falls to the ground. It's going to fall to the ground because of gravity. It's going to fall to the ground because it just is way heavier. Where is the picture? All right, I'm going to have to find it later. Okay, so that's what precipitation, the general definition is. There are 6 types of precipitation, and yes, you are responsible for knowing, okay, the different types and what they mean. And of course, I am going to do this with you and go through that in detail. Okay, so the 6 types are rain, drizzle, sleet, snow, hail, or freezing rain. So far, over the last couple of weeks, we've seen rain, we've seen sleet, and we've seen snow. Okay, we have not necessarily seen drizzle that much. We don't really see hail that much, and freezing rain I have not seen this winter yet. You never know, right? Well, let's talk about them. Now, again, if you guys would like to take a picture of this, you are welcome to put it into your notes. All right? Here's how rain, freezing rain, sleet, and snow form. They all start off the same. And depending on what kind of temperature they hit on the way down is going to tell us what kind of precipitation it is. Rain is the easiest. They all start off as snow in the cloud. Okay? Rain is the easiest one to actually see because you already know what that looks like, right? You have, it start off as snow inside the cloud. Then as it falls down to the ground, it hits warm air, warming up those snow flakes, right? And melting them. So it needs to be about over 32 degrees Fahrenheit or 0 degrees Celsius, right? Because remember, this is not pure water. This is water that evaporated from the ground. And you know we have other stuff in our water besides just hydrogen and oxygen, right? It's going to pick up any sort of pollution that was in the water and going back up. So all of that stuff is going to change the melting point of water. So that's why sometimes you don't want it to be just 32 degrees Fahrenheit in order to get a snow day, right? Because 32 degrees means that we could have rain or snow, okay? So in order for rain to form, it comes down, hits some warm air, completely melts the snowflakes, right? And hits us as water. That's the easiest one because you know it, you love it, don't want to go for it. Freezing rain is different. It follows the same pattern as rain, except when it hits something, it freezes. It's actually one of the prettiest things I've ever seen. You've seen it before, not recently, but you've seen it before last year, okay? When the rain comes down, hits the trees, and it looks like the tree branches are like actually encapsulated in ice, okay? That's freezing rain. You probably have not seen it yet because usually on the days that it has happened, you guys haven't had to go to school, so but have you ever gotten up in the morning and you go to get in the car and it's raining out, or it's not even raining out, but you go to move the door handle and you hear the cracking of ice? That's because freezing rain had happened. Water came down, and when it hit the car, right, it froze, which then keeps your door handle from moving. Okay? Now, you have seen more sleet than hail. The other day, when it was supposed to rain, it ended up sleeting. How do I know? Because it sounded like ding, 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 ding. It sounded like somebody was throwing little tiny ice chips at your windows. You guys were home during it. It was during break. Well, hopefully you were home and not hanging out with a bunch of people. Hopefully. Okay? So sleet happens. It comes down as snow. It hits some warm air, so it melts into rain. But then before it hits us, it hits some cold air, which then refreezes it into little ice chunks. Now I say little ice chunks because sleet is way different than hail. Okay? Everybody automatically assumes that those little tiny ice chunks that are hitting your window are actually hail, and it's not. Okay? Understand that this goes from snow to water. So it goes from snow to or a big dog outside, and they're just like, what is going on? And they freak out. It's like bouncing off their head. You've met Raja. She's very dookie. Okay? And snow's the easiest, right? It comes down out of the cloud as snow, stays as snow, falls to us as snow, never melts on the way down. Okay? Questions? Okay? So how do I know the difference between sleet and hail? So sleet is when it comes down from the cloud, melts, and then refreezes. Hail, however, forms inside the cloud. This is the big difference. Hail forms inside one of those cumulonimbus clouds. All right. So, what happens? This picture says it all. So again, if you'd like to take a picture of it, you can. Right? This block here is actually the cloud itself. It's supposed to be representing the cloud. You know that inside those clouds are pieces of water vapor, right? So they condense down and freeze. Well, inside those cumulonimbus clouds, that's one of those big clouds that look like you just dropped a bomb, right? It's one of the big clouds, right? There's some currents that are happening. Wind is being sucked up into it, which then takes that little water droplet down, right? And then sweeps it back up and refreezes it. And then it wants to fall back down because gravity always wins, and it hits it back up. And then it refreezes, and then it comes back down and up and down and up and down. And depending on how many times it melts and refreezes and adds water and refreezes and then melts and refreezes, it gets bigger and bigger and bigger. And eventually it falls out of the sky, producing this. This looks like it's really close-up pictures of rain, but it's not. This is large ice chunks that formed inside the cloud falling down to Earth, causing this kind of damage. Okay? Now, on the left here, we have actual hail that came out of clouds. On the right here is the damage it caused. Okay? Here's the crazy thing. I found a video on epic hailstorms. Now, this is a combination or collaboration of different hailstorms over different places. Okay? This will happen to this extreme, mostly inland. It does, however, happen to us every once in a while, but not this bad. That's ice coming down about the size of a golf ball. Imagine walking through that, because I wouldn't. Okay? Our last hailstorm in New York was in July of this past year. But it was not to this extent in any way, shape, or form. So notice it's raining. It's raining. It's no longer raining. You hear the difference? It just cracked the windshield. Now, this is one of those things that are considered to be an act of God on your insurance. So if you were driving through this, right, and your windshield cracks like this, you claim it with your insurance as an act of God, and hopefully they should cover it.
Hail the size of a golf ball.
So it's coming out of their gutter.
And 2 inches in diameter.
So the best thing for you to do during a hailstorm is to not be in your car. You're better off being under a covering that's sturdier than glass. Because you can see what happens to glass. It's like being hit with a golf ball. Sometimes larger. at full speed. Yeah, technically you can't drive with a cracked windshield like that. You're not supposed to, at least. See that happening? You know that happening? Look where the ice hit was this corner, right? Right. Because remember, all of those active shooter drills, what do they tell you to do if you need to get out of the window where you're supposed to hit it? In one of the corners, because that's the weak spot. It shatters the whole thing, and then you can just knock it into it. In this case, it just collapsed. And this person's trying to hide out. They probably pulled over. They've got glass on them. With it shattering and coming in, it broke the back window. So now you have glass and the ice coming in. This is the aftermath of what happened. How crazy is that? Look at all the marks on the top of their car. It looks like you took a whole bucket of golf balls and dropped it off the side of a building and have it hit their car. Look at all the dents. I don't think I might have gotten video from our store. Don't mind the language. No. Yeah, if your car was outside of this, it would be completely total. Look at the size of some of them. They're lucky they have a covering for that RV. This is also why, guys, one of the questions on your insurance says, where are you going to leave your car? Are you parking it on the street or are you parking it in a garage? Because if you park it on the street, you have a higher rate or higher probability of something bad happening to it versus if you park it in your garage or in a garage. This is what scares me about driving inland more. Look how fast that happened. With 4 people. Notice how they're coming up from the stairs and they're running because you don't want to get hit by any hail. It hurts. I'm going to skip ahead a little bit because I want to show you. Look at the pool.
It looks like it's being shot
Like a machete, yeah, like a ridiculous gun, yeah. Well, see, if you notice in the pool, guys, also, one of the things that I've been telling you about is that ejecta. You see how it's splashed up like that? That's the ejecta that's coming out from the pool, like when we talk about volcanoes. That car may get lucky because it's underneath a tree. It'll actually slow down the hail, but not by much. See, look at this pool. So as you can see, hail is very dangerous. But you have to remember that that is formed inside of the cloud. Okay? And that's the difference between that and sleet. Okay? That's very important. Sleet forms, it comes out of the cloud as snow warms up, goes to rain, and then continues to refreeze before it hits us. Hail just happens inside of the cloud itself. Right? It gets bigger and bigger and bigger, and it comes out as those ice chunks. Okay? Rain is the easiest one that you know, because you've seen it all. We had some the other day. We're going to probably have rain this week. Okay? It's the most common form of precipitation. Okay? When you have rain, what happens is that that snow comes out, right? It's going to be ice crystals. Ice crystals are snow. If you ever look at snow under a microscope, it's tiny little ice crystals. Tiny, 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 tiny. And then when it comes down, it warms up, melts, and hits us as rain. Rain should be the easiest one because you should all be able to understand it. You've seen it a million times. Okay? This is what happens, right? They have different sizes depending on how fast or slow they melt as they come down. Okay? Sometimes you have those big drops of rain. Sometimes you have little tiny drops of rain. Right? We've all seen the difference. Okay? Freezing rain, we said, right, starts off as the snow. It melts, comes down, and refreezes when it hits something. So it can refreeze by hitting the ground. It can refreeze on the grass. It can refreeze on trees, on your car, so on and so forth. And this is very dangerous because when it hits the ground and freezes, it creates ice. And I want to show you a really pretty picture of what this looks like. Because it is very pretty to look at. But it's also very dangerous because it's creating that ice, right? Which means that you can drive on it and skid. You can walk on it and slip. But also, if it does refreeze around a tree or a tree branch, right? It makes that tree branch heavier, which means that it can break and hit you. Or it can fall off as giant weapons. Because ice is not something to mess around with. Okay? That's what it looks like. It is very, very pretty. It looks like the tree has been encased in ice. You see that? It almost looks like it has like a protective covering around it. Right? So we've talked about atmospheric transparency before, right? And how condensation and precipitation is going to actually remove that pollutants in the air, right? So the transparency of the atmosphere is how easily insulation is going to pass through it, right? Aerosols or pollution will actually affect it. The more aerosols of pollution you have in the atmosphere, the less likely the sun can come in and the more warming we have of our Earth itself, okay? Right, because it traps some of the infrared radiation from leaving. That last dot is review because that was on your test. All right, guys, you have a good one. Be good. I'll post your practice problems. I'm not grading them, okay? But I will post them for you guys. Be good, guys. Stay safe. Don't do anything stupid.